Let's continue looking at absolute value inequalities. Let's look at a couple problems that people consider trick problems, or at least they're tricky. So here's the key. The key is that when you have an absolute value of a number, it's always going to be it's always going to be a positive number. So if y is negative, the absolute value of a negative is going to be positive. So this is a positive number. But if y is a positive, the absolute value of a positive number is also positive. So this always has to be positive. So if you had absolute value of y is less than or equal to, say, a negative number, minus 7 for say, you know that that's not possible. Since that's not possible, then you say no real solution. And another example of a trick problem is, let's say the absolute value of z is greater than or equal to a negative number. When is absolute value of a number greater than or equal to a negative number? Well, it's always greater than or equal to a negative number. So that's going to be all real solutions or all real numbers. And the graph of it is simply going to be a number line where every single point is shaded. Let's look at an example. It'll just say solve or possibly solve and graph. And you'll have 2 absolute value x plus 3 plus 18 is 4. Sorry, let's say less than or equal to 4. Your first step, isolate the absolute value term. So you're going to subtract 18 and subtract 18. 2 absolute value of x plus 3 less than or equal to minus 14. Let's divide both sides by 2. Absolute value of x plus 3 less than or equal to minus 7. At this point you can stop because you know that the absolute value of anything is going to be positive. When is a positive less than a negative number? Never. So your answer is simply no real solution. Sometimes they call this the null set, so some people will say this is the symbol for that, null set. We don't say the null set, that's just the symbol for no real solutions. Let's look at another example. Let's do 4 plus 2, absolute value of x minus 1. Let's do greater than or equal to 1. I'm going to isolate the absolute value term, so I'm going to subtract 4 and subtract 4. 2, absolute value of x minus 1, greater than or equal to minus 3. I'm going to divide both sides by 2, so we get absolute value of x minus 1, greater than or equal to minus 3 halves. So let's think of this. An absolute value term is always positive. When is it greater than or equal to a negative? It's always greater than or equal to negative. So here we'd say all real numbers or all real solutions. Sometimes people will use an R symbol. And that simply means, this is simply a symbol meaning all real numbers. Two other problems are a little bit tricky, and that's when you have a 0. So let's think about this. Absolute value of x greater than 0. So when is the absolute value of x greater than 0? The absolute value of a number is always non-negative. But the trick is that it could be 0. So what's the absolute value of 0? The absolute value of 0 is 0, and 0 is not greater than 0. So this would be all numbers except 0. Where if it was absolute value of x is greater than or equal to 0, then that would simply be all real numbers. Negative works a little bit similar. Let's say the absolute value of y is less than 0. Absolute value of y is always positive, so it's never less than 0. But if it was less than or equal to 0, then the solution would be y is equal to 0. Here it would be no real solution. Let's think that through for a second. Absolute value of a number is less than 0. Absolute value of a number is always positive. A positive number is never less than 0, so there's no solution. Absolute value of y is less than or equal to 0. That can't work unless y is 0. If you have the absolute value of 0 is 0, and 0 is in fact less than or equal to 0 is equal to 0. So those are two more little trick problems to worry about as well. So that's how you solve absolute value inequalities, with what might be called trick problems, or at least tricky problems.